We will solve gate questions on trapezoidal rule and Simpson rule. Please like, share and subscribe this particular channel. Come to the questions now. The first question is the order of error in Simpson rule for numerical integrations with a step size of h is. It is asked in 1997. And same type of question, the accuracy of Simpson rule quadrature for a step size of h is in 2003. Okay, now we know the errors of a Simpson rule and trapezoidal rule. The formulas are nothing but for trapezoidal rule, error is less than or equal to b minus a whole cube by 12n square into maximum of mod of 2 times derivative of f of x, and x is between a and b. And similarly for the Simpson rule, error formula is given as b minus a whole power 5 by 180 into n power 4 into maximum value of mod of f of 4 times derivative of f of x, right? Where x is would be in between a and b. As we know that h is nothing but step size. H is equal to b minus a by n. N is number of intervals, right? So they're asking for Simpson rule. So if you substitute this particular values, okay, we can consider this one as nothing but h power 4 into b minus a, and formula will be same, divided by 180 into maximum value of mod of f of 4 times derivative of x. So it is nothing but accuracy or order of error is given as h power 4. So answer is option D. And for this one, it is an option C. Coming to the next question. The question is a second degree polynomial 0 to f of x dx has a values of 1, 4 and 15 at x is equal to 0, 1 and 2 respectively. The integral f of x dx is to be estimated by applying the trapezoidal rule to this data. What is an error in the estimate? They are given the error is nothing but true value minus appropriate value. First we'll understand the question. They are saying about the second degree polynomial, right? So if you consider something function f of x is equal to ax square plus bx plus c, okay, and we are given the integration of from 0 to f of x dx, from 0 to 2 f of x dx, which is equal to nothing but, if you consider this one x naught to x of n f of x dx, right? Now they are given the values of it, right? F of x is equal to 1, 4 and 15, and they are given the value of x, another one 0, 1 and 2. Now they are asking us to find the error. Error is nothing but true value minus appropriate value. So they are given that error is equal to nothing but true value minus appropriate value of it. When you get the true value is nothing but when you integrate it from 0 to 2 f of x dx, and approximation value is nothing but when you use a trapezoidal rule formula to find the value of it, right? Now first what you do is nothing but, for this one, first find the value of f of x, right? For f of x, we have to first find out the value of a, b and c. We know the initial values here, right? So we're finding the value of a, b, c. If you consider f of 0 is nothing but it is equal to 1, which is equal to nothing but x is 0 here, then it becomes 0 plus 0 plus c, and we get c is equal to nothing but 1. Again going to the second one, f of 1, which is equal to a plus b plus c, which is equal to nothing but 4. We know c value, it's 1, so we get a plus b is equal to 3. Now coming to f of 2, then it becomes nothing but 4a plus 2b plus c, which is equal to nothing but given as 15, right? When 2 it is 15. right? So it becomes nothing but, we know c is equal to 1, then we get 4a plus 2b is equal to 14. Remove the 2 from here, so we get 2a plus b is equal to 7. But we know that a plus b is equal to 3, so we can get the values a and b here. A plus b is equal to 3. Subtract it, then we get a is equal to 4. Again, if a is equal to 4, then we can get from here b is equal to nothing but minus 1. So we got a function f of x. So we can say that f of x is equal to nothing but ax square, means it becomes 4x square, and b is minus 1, so it becomes minus x. It is plus 1, right? Now we will find the true value. It is nothing but integrating from 0 to 2 f of x dx. We know f of x is nothing but 4x square minus x plus 1. So we are defining the integration from 0 to 2 f of x dx, which is equal to nothing but it becomes 4x cubed by 3 minus x square by 2 plus x. It is from 0 to 2, right? So just substitute the values here, then we get 4 into 2 cube 8 by 3 minus 4 by 2 plus 2, right? Goes one in 2 and minus 2 plus 2 get cancelled. So value is equal to nothing but it becomes 32 by 3. So true value is nothing but 32 by 3. We got it, right? Now we have to use a trapezoidal rule formula to find the approximate value, right? Now using it a trapezoidal rule. The formula that we know is nothing but integration from x naught to x of n f of x dx is equal to h by 2 into y naught plus y of n plus 2 times of n y1 plus y2 plus so on to yn minus 1, right? Here they are saying that n is nothing but 2 intervals, right? If you consider this one, we consider 2 intervals, 1 and 2. So n is nothing but, we can say n is equal to 2. Next we have to find the value of h, right? For the h, the formula is given as nothing but x of n minus x naught by n. X of n and x naught is given as nothing but 0 to 2, right? So substitute the values here, it becomes 2 minus 0 by 2. So h is equal to nothing but 1. We got it. So just substitute the value. So we get it as nothing but h is 1. So it becomes 1 by 2 into, it is a y naught plus y of n means becomes y of 2 plus it becomes 2 times of n y of 1, right? What is that? Y naught is nothing but f of x at 0. This is a y naught, this is y1, this is nothing but y2. So just substitute the values here, then we get as nothing but 1 by 2 into y naught as 1 plus 15 plus 2 times of n nothing but 4. So it becomes nothing but 8, right? So substitute the value here, then we get 1 by 2 into, it becomes 16 plus 8, it becomes 24. So just substitute the values, you get as 12. So by using a trapezoidal rule, it becomes nothing but 12 value. So it becomes minus 12, which is equal to nothing but, take an LCM, it becomes 32 minus 36 by 3, which is equal to minus 4 by 3. So what is an error? Is nothing but minus 4 by 3. So answer option A. The next question. The question is, the table below gives value of a function f of x obtained for values of x at the interval of 0.25, and x values are given and f of x values are given. Now they are saying the value of the integral of the function between the limit 0 to 1 using Simpson rule. Okay. Now we have to find the value of it by using a Simpson rule. General formula of a Simpson rule is given as integral from a to b f of x dx is equal to h by 3 into y naught plus y of n plus 4 times of n y1 plus y3 so on to y of n minus 1 plus 2 times of n y2 plus y4 plus so on to y of n minus 2. This is a general formula of a Simpson rule. Now we will be finding the values of it. Here h is given. H is equal to nothing but we know as b minus a by n. Here although the interval is given as 0.25, right? So which is equal to nothing but 0.25. If you want you can calculate it, okay? How many intervals are there? 1, 2, 3, 4, right? B minus a is given here. Limits are from 0 to 1 it is given. So a is nothing but 0, b is nothing but 1. So it becomes 1 by 4. It's also 0.25. Now we'll be finding the values of it. Come into y naught and yn. N is nothing but 4 intervals. So we can consider n is equal to nothing but 4. So 1 becomes nothing but y naught. This one becomes y1. This is y2. This is y3. And this is y4. Just substitute the values here. Then you get h by 3 into y naught plus y of 4 plus 4 times of n y1 plus y3 plus 2 times of n y2. We know the values. So it becomes h is 0.25 by 3. Y naught is nothing but 1 plus y4 0.5 plus 4 times of n y1 0.9412 plus 0.64 plus 2 times of n y2 0.8. So substitute the value, we get the value as nothing but 0.7854. Okay, so the value we get is nothing but option A by using Simpson rule. Come to the next question. The question is a differential equation dx by dt is equal to e power minus 2t ut has to be solved using a trapezoidal rule of integration with a step size h is equal to 0.01. The function u of t indicates a unit step function. If x of 0 minus is equal to 0, then value of x at t is equal to 0.01 seconds will be given by. Okay, first we'll understand the question. They are given the differential equation, right? It is given as dx by dt is equal to e power minus 2t u of t, and we have to use a trapezoidal rule. We know the trapezoidal rule formula is given as integration from a to b f of t dt is equal to nothing but h by 2 into y naught plus y of n plus 2 times of n y1 plus y2 plus on to yn minus 1. Right. Again they are given the step size that h is equal to nothing but 0.01. Right. Function u of t indicates a unit step function. Right. So they are given that u of t is an unit step function. So u of t is equal to 1 for t greater than or equal to 0, and it is equal to 0 for t less than 0. Right. Again they are given that f is equal to x of 0 minus is nothing but 0. If you draw this particular e power minus 2t graph, then we will be getting in this particular format somewhat, right? So it is given that x of 0 minus is equal to 0. This is nothing but an x function, right? It is 0. So from 0, from the axis we will be consider the values. Below it, it's nothing but 0 value, right? So we get the graph as nothing but it becomes in this particular format, right? Now they're asking us to find the values, okay, at t is equal to 0.01 seconds using trapezoidal rule. What they're saying is nothing but at t is equal to 0 to 0.01, okay, x value is given as nothing but e power 0 and e power minus 0.02. We have to find the area from here to here is how much, right? How many intervals are there? Only one interval. So n is equal to nothing but 1. Here all the values are given. H value is given as 0.01, right? So just after the value we get as 0.01 by 2 into y naught is nothing but y naught plus n is 1. So it becomes 1 y of n. This is nothing but y naught. This is an y1. So we get as 0.01 by 2 into 1 plus e power minus 0.02. Use a calculator, get the value as nothing but 0.0099. Okay, so answer the option C. Come to the next question. The question is the minimum number of equal length subintervals needed to approximate 1 to 2 x e of x dx to an accuracy of at least 1 by 3 in 10 power minus 6 using a trapezoidal rule. Right? What they are saying that we have to find the equal length subintervals we need. Okay, we have to find the value of n is equal to how much, right? They are given the functions here. So it is not but integral a to b f of x dx is given as nothing but integral 1 to 2 x e power x dx, right? And they given the accuracy as 1 by 3 in 10 power minus 6. So we can say that accuracy is nothing but error we may get is equal to 1 by 3 into 10 power minus 6. You have to find number of subintervals using a trapezoidal rule. So error formula of a trapezoidal rule is given as b minus a whole power 3 by 2n square into maximum value of mod of f double dash of x, where x would be in between a and b, right? By using this formula, we have to find the value of n now. Just we have to find double dash of x is nothing but 2 times differentiation of x. Here f of x is equal to nothing but x into e power x. Then f dash of x is equal to e power x plus x into e power x. Then f double dash of x is equal to, it becomes e power x plus e power x plus x into e power x. So maximum value from a to b. A is nothing but given as 1. B is given as 2. So from 1 to 2, when is the value f of double dash of x maximum, right? If you substitute the value as 2, then we get a maximum value, right? So it becomes nothing but f double dash of x at 2, okay? It's given as e square plus e square plus 2 into e power square, which is equal to nothing but 4 e square. So just after the value, we get this one as b minus a. It's not but 2 minus 1. So it becomes 1 cube by 12n square into the maximum value we got as 4 e square. This is nothing but 1 by 3 into 10 power minus 6, right? So it goes 1 3 and 3 get cancelled here. So substitute the values here. We get 10 power minus 6 is equal to e square by n square. So we get the n square value is equal to e square into 10 power 6. Then n is equal to nothing but 10 power 3 e, right? Which is equal to nothing but 1000 e. So number of subintervals is nothing but option A.